If you think back to the 1970s when the Apple II Plus and the Commodore PET and the TRS-80 Model 1 came out, those were like the first three really popular home computers. Of course, there were home computers before that, but ones that were mass produced and sold in stores you could just walk in and buy. There weren't really computer monitors yet. If you look at pictures, at least early press pictures of the Apple II, that particular computer was designed to be used with television sets. A lot of people paired it with an RF modulator, or if you wanted a higher resolution monochrome text display, people would use things like this. This is a security camera monitor that was common on the market at the time. They typically came in 9-inch, but I think there were 12-inch variants as well. They were pretty expensive because these were commercial displays. Let's zoom in a little bit on this one here. This is a Koyo version that I picked up at Goodwill. It's a thrift store in the US here years ago, and I got this for like $5 or something like that. This has a white phosphor 9-inch CRT, and well, it's a commercial monitor, meaning, well, it's all stuck on crap that I have on my desk here. It means that it's built like a tank. This thing is full metal box cube construction. It has a 3-prong grounded plug, and even the video input is just a BNC jack. And it even has a pass-through here, so you could hook this up to multiple displays. The thing that was really good about these monitors, when used in conjunction with computers, is they were very high resolution. I don't think that was really on purpose, but this particular screen can display 80-column text with no issues whatsoever. I think that's because they figured for security camera purposes, you wanted to have high resolution so you could see the perpetrators who were breaking into your business or whatever was going on and doing bad stuff. So you wanted to make these pretty high quality. They're also very reliable, of course, because they were designed to run 24/7. And that's one of the problems these days. If you're trying to find one of these, a lot of times they have a pretty significant burn-in because they were used for their intended purpose for 20 years or whatever it was, and they got the burn-in on the screen. So with those early Apple IIs and a lot of the precursor machines before that, stuff from like the mid-70s and onward, a lot of people were using these. They wanted a nice crisp display. But if you couldn't afford something like this, because they were pretty expensive, a lot of people hooked up a television set to their computer as well. Now with the TRS-80 Model 1, that thing actually, you could get a bundled monitor from Radio Shack. And of course the PET had a built-in screen, so you didn't have to worry about an external monitor. It didn't really even support one. But for things like the Apple II, and of course many other home computers that came out after, they typically hooked up to your video display with either an RF signal or a composite video signal. Now in the 70s, composite video on television sets was super uncommon. That's why people were using these. They had that composite input on them, and that was one of the things they could do that a regular television that you picked up at the store could not do. Those would only have an RF connection, and RF is not really good enough for displaying 80-column text. It's okay with 40-column text, but you get a lot of snow. I mean, if you don't have, especially you don't have a good connection to the RF, it just doesn't look that good. And I think a lot of people grew up using, say, a Commodore 64 or a VIC-20, and they were hooked up to a cheap, inexpensive black and white television over RF. And they were just, I mean, it was all you knew, and it worked, but you were just used to getting some static on the screen and whatever, you know, it's just how it was. Now in the late 70s and into the early 80s, Apple and Commodore and these companies, they weren't yet selling computer monitors. They didn't yet have their own monitor. So the companies that were selling CRT-based displays, and this one here is made by Zenith, they started taking their television chassis, and you can kind of tell by looking at this thing, you know that this was a television at some point, and they started adapting them for use on computers. Now what Zenith did with this one, and we'll look at the model number in a second, I can't remember off the top of my head, is they swapped out the white CRT from the black and white television that this thing was originally, and they put a green phosphor CRT in here. Now I've shown this trick off before, but if you want to figure out what color phosphor the CRT is, there's a good way to do it. You can use one of these cheap UV LED flashlights you can get for just a few dollars. If you shine this at the screen, I'm going to do that even with all the lights on, it makes it glow green. And I mean, it's a bit washed out in the camera, but to my eyes, that is an extremely bright green splotch in the middle of the screen. Now if we go to the Koyo here, and I do the same, now it's glowing white. Now you can see the reflection of the LED flashlight. I'm going to move it off axis here so you don't see that. That is a kind of cool white phosphor right there. That's what that looks like to my eyes. Now on the camera, it may not look like that, but over here, there it is. That's a pretty great way to tell what color phosphor you're looking at. So as I said, these show up as white under UV, green shows up as green. And sorry, we're here in the dungeon part of the basement. I wanted to just demonstrate the final color. This screen here, this is an AMDEC composite monitor, and it has an amber screen. And if I shine the LED flashlight on this, it shows up as purple. So for whatever reason, amber shows up as purple, green as green, and white as white. Why doesn't this show up as amber? I don't know, but that's just the way it works. Let's do another demonstration on my Apple IIc monitor here. These should be green, right? Ah, it's showing up as white. But yeah, that's actually because I have a white CRT swapped in there. And then on this Mac Classic sitting here, green, showing up as green. Yes, because that has a green CRT swapped into it. Anyhow, sorry for that tangent. It's just kind of fun to show off the UV flashlight. It's just handy if you're quickly trying to tell the color. Zenith just took one of their televisions, replaced this panel with a plate to cover up where the old tuner knobs were, put a green CRT in here. On the front here, we have black level and contrast knobs that are down here on the front. We have what would have been the power switch and the volume knob originally. This would have been a knob you turned or maybe pulled to turn on the TV, and then you turned it for volume. Well, now it's just a on-off switch. And if we look at the back here, you can really tell that this was just a cheap consumer black and white television originally. At least that's what it started at. And instead of reinventing the whole chassis and starting from scratch, I guess it was just quicker for them, and cheaper obviously, to turn a television into a monitor. Now looking at the back here, we have a regular 2-prong power cord, which was very typical for US domestic black and white televisions, consumer TVs. It even has these clips, or not clips, I don't know, whatever little things here, zoom in a little bit on that, for cable management. Very common for these TVs because they were designed, the black and white originator of this set was designed to be portable. So it's got a handle here even, so you can pick it up and move it around. It doesn't weigh that much. This was a little portable 12-inch or 13-inch or however size this is TV that was designed to be moved around easily so you could watch your television, anywhere that is. And then as was super typical, this was the RF inputs, and there would have been 2 sets of screw terminals. And yes, in the late 70s, which I'm sure is when this TV was designed, we were still using screw terminals in North America. So there were 2 screws on the top, probably for VHF, and then 2 on the bottom for UHF. And there would have been a mount on this TV somewhere, and you can see, it looks like, I don't know if that comes across in the camera, it looks like the plastic here had something right there that was then filled in the mold. And I wouldn't have been surprised if there was something there to mount rabbit ear antennas. But they replaced that little panel with the RCA cinch type connector for the video input. They also added a width control here, which I'm assuming is a coil, because it turns not like a potentiometer, so this is probably some kind of a coil inside to control the width of the image. And then you have a switch here that says, it says 40 or 80 on the right side, and it says characters. I don't know what that does. Maybe it makes the image softer for 40 column text? I don't fully know. Now over here we have the model number of this TV/monitor abomination. It's the model number ZVM-121, and this is made by Zenith, of course. There's a chassis code there, which might be shared with the original TV, but I doubt it, because I think they've changed quite a bit on the inside of this thing. Serial number for this particular set, UL listed, is stuck right in the plastic there. That could have been left over from the original television, who knows. And then if we look down here, let's get this power cable off of here. We have some controls. So it appears we have a size control down here. I don't know if that's coming across in the camera, but it's a size control. You gotta stick a screwdriver in there. That's gonna be vertical size. And that would have been there on the original television. Horizontal size was never something you could adjust on cheap TVs like this thing. So they added the control over here with that coil inside. And then there are two controls here. Probably one of them is horizontal hold. I can't read it from where I'm sitting here, but horizontal hold, so that's horizontal frequency, and then a vertical hold. So both of those adjust the frequency. And the fact that it has a vertical hold control actually means that this monitor would work perfectly at 50 hertz or 60 hertz. And I mean the input frequency. So if you plugged in a PAL computer, you could get an actual stable image because you would just have to adjust this, the vertical hold, if that's what whichever one is vertical hold, and then you would adjust the size control to shrink the image down. When you have 15 kilohertz video at 50 hertz, you have more lines. That's it for controls. I mean, we just have these 4 controls on the back here, plus the 2 on the front for brightness and contrast, basically, or brightness and picture level, so black level and white level. And the last thing is this sticker here. Let's look at that. Hopefully this is coming across, but this was manufactured in April 1982. Now, I have no doubts that this monitor was probably released even before 1982, because computers were starting to really become popular, and not just the Apple, but other machines as well that you need to plug into a monitor, and you wanted high resolution text, and well, there just wasn't any options. You're either going to be buying one of these small commercial monitors, which are very expensive, or trying to hook up to a crappy TV, and this was their sort of interim solution. Now, of course, it didn't last long. It was soon after, I think maybe 1983, I might be having my dates wrong, Apple released their Apple Color Monitor 3. 3, there we go. That was in conjunction with the Apple III. That was their first monitor. I've shown those on the channel before, and those were pretty great monitors. If I recall, they were designed and OEM'd by, was it Sanyo? I can't remember. They didn't make the monitor, they designed the industrial design of it, I guess. It was not so much just adapted television like this one was. It was a little bit more bespoke. On the other hand, it still has some lineage of it having probably started from a TV as well, because it kind of has this panel over here. And on this one, I bet you when we open this up and look inside, we're just going to see like the holes for the tuners. The Apple Monitor 3 doesn't quite have that, but it has like the contrast knob and a power switch over here. So it still has this side area here, which is clearly not needed. There's no reason for that to be there in a set like this. I wouldn't be surprised when we open this thing up, the PCB that runs the monitor is going to sit over here underneath the CRT, and there's a bunch of empty space over here, which would have originally held a speaker and the tuners, and those things sit here, especially the tuners. They take up quite a bit of space right there. And I bet you the original speaker grill was probably down here at the bottom, volume knob, as I mentioned. Now, one of the reasons why just taking a regular black and white TV and using it as a composite video monitor isn't as easy as you would think, because if you look inside a monochrome television set, the tuner, you know, tunes in the RF, and then it goes through some intermediate stuff, and then it is turned into composite video internal to the set and then displayed. The sync is separated out, video is separated out. Why is it hard to just give composite video? Why do they have to make these little sets like this? Well, the main reason that it wasn't super easy is that in North America, our line voltage here is 110, 120 volts. And that means that pretty much all black and white TVs and most color sets are hot chassis. The B plus in the sets in the 70s and into the 80s, they just ran close to regular line voltage. And I think in most of the world where you had sets that were running at 240 volts, you probably needed a transformer. And when you have a transformer, you're isolating the AC mains from the electronics inside the set. But when you're running a hot chassis, it just means you're rectifying the AC coming in from the mains, smoothing it out, running it through a very simple pass type voltage regulator, which just burns off the extra voltage as heat through some big power resistors, and then you're powering up the entire set. Well, the problem with that is the cord on this set is polarized, so the neutral should, always be neutral, and hot should be hot, or live, whatever you call it. Problem is, you might have an incorrectly wired outlet. Someone could cut the cord and put a new outlet on there. It doesn't have polarization. You just never know if someone has switched this around and what was the neutral is now the live. Well, if you do switch it around, think about the fact that the composite video connection that goes into the circuitry that then displays on the set, well, you need a ground and you need the signal, right? There's 2 pins here. Well, On a live chassis set, it's quite possible that one of these pins is connected directly to the ground right here. And if you flip this around because of a miswired plug or outlet or whatever, then suddenly you have 120 volts right here at this jack. That's dangerous. Obviously, you can't do that. You really don't want to do that. Now, if you're wondering on old TVs, how did they have those terminals here for the tuner? Well, because there were little matching transformers inside the set. So those screw terminals were not directly connected into the rest of the set. But to hook up composite video, that needs to go right into the circuitry of the set. It's a little more difficult. And if you put a transformer in there, like a line transformer to isolate this from the set, well, you're gonna lose fidelity. And if you're trying to get 80 column text razor pin sharp, putting a transformer in there in between this RCA jack and the circuit board in the set, it's not really feasible. It just won't result in that good of an image. Now, it's possible with a whole bunch of work, maybe you could do it, but ultimately manufacturers, what they chose to do, and I'm sure when we open this up, I haven't looked inside this set, I bet you there's a big power transformer in here. So the mains here goes into a power transformer, and then that outputs some AC voltage, which is then rectified, smoothed, and then goes into the CRT board. And if you look in any of these 80s computer monitors, they have a big honking transformer to do exactly that. And when you have a transformer, you have galvanic isolation. You are isolating the entire electronics of the set from mains. So no matter how you plug this into the wall, it doesn't matter. This is always going to be safe to touch. You're never going to have an issue. Therefore, if you plug this in your Apple II, it's not like your Apple II is going to become live. It's safe to touch, etc., etc. So in its original television form, there's no way this would have ever had a transformer in here. Almost certainly, I mean, I'm assuming this would have just had that simple voltage regulation. And therefore, yeah, this is kind of a redesign on the inside. Obviously, the chassis is the original TV chassis, except, well, I mean, we'll see when we open it up. But CRT, is green now, and it's a higher resolution one probably, if that's even a thing. But the main difference is, yeah, it's going to have a new display board just to accept composite. It's not going to have any support for tuners or audio or any of that stuff. And then this will have a transformer in here. So the internals will look quite different. And later monitors, like the Amdex and pretty much everything else, is going to work the same way. It's going to have the transformer stuff. And in fact, these monitors, these Koyos here, or these security camera monitors, absolutely used power transformers in all of them. And that's one of the reasons why this thing is super heavy. Obviously the metal, doesn't help with the weight either. But yeah, let's have a big transformer inside, because it's really the only way back then to make it safe to have those grounded jacks on the back, those composite video. This thing was designed originally, this Zenith was originally designed as a hot chassis. So it's entirely plastic and nothing, well, this is metal right here, but no part of the outside of this set is actually connected to the inside. Everything like the knobs and stuff are all plastic. And that again was because this thing was designed as a live chassis and could be dangerous to touch anything on the inside because of that situation. So the fact that this is all plastic, it just means that they don't quite have to work as hard, and you don't really have to worry about having this grounded, because the only mains part of the set is whatever the transformer is, which is going to be over here. And then that goes, well, the ground on this RCA jack is not connected or associated mains in any way. It's isolated because of the transformer. Now, lots of manufacturers did this sort of adapted TV thing for their computer monitors. And of course, I already mentioned it, but here is the monitor from the TRS-80 Model 1. And yeah, if you know this thing, I'm pretty sure this is an RCA television set that was adapted for use by Radio Shack for the computer. And I can't quite remember, but I'm almost positive that this still uses most of the original circuit board for the TV. So this is not really designed for high resolution display. It's more like a television in there. It does not have a transformer. And you're probably wondering, well, how do they create this isolation? Well, this thing, what they did is they created this little circuit board that is powered by the computer. So this multi-pin connector here has not only a video signal, composite video, but it also has 5 volts and ground. So it's actually powering up this little circuit board, which has like a buffer and some stuff on there that isolates this from the set. So I think that board, I've never really looked at the schematics for it, but I've looked at it. It plugs in as a little module into the main board inside here. And I bet you the original board had like a tuner thing or something that plugged in there and something else. And I know the Radio Shack board is pretty small, but it has, you know, several ICs and parts on it. I bet you it's doing some kind of isolation right on that board. And I'm quite sure that that board in this monitor is actually getting a TTL type signal through some buffers. I think. I might be wrong about that, which would mean that it can only display either full white or full black TTL, right? On or off. This is just a regular composite monitor. You could display anything on here, like a video signal. You'll have all the shades of gray you could imagine. Don't think that's the case on this thing. And of course, when you look at this, this thing is absolutely like, this panel right here is like kind of loose. So I think if you pull this hard enough, the knobs, or where the knobs would have gone for the tuner, you could see it back there. These have these controls here, which I think on the original TV are for brightness and contrast. And then where this wire goes through here, which says V, I guess for video, would have originally been V for volume. This would have been the television's original speaker, so that's missing. So the power switch right here, you turn it off and on, and then you adjust the volume down here, and yeah, now it says video. So this whole thing is just hilarious. I know in Europe, they did not use this chassis, they used something else, probably a TV as well, but this thing was what they came out with in North America in 1977. Anyhow, so with all of that said, the purpose of this video is I want to actually see if this thing works. I've had this thing up in my office for a while now, and I have never turned it on. I wanted to take a look at it on camera here for this video, so we could actually, you know, see what's happening on the inside. I think these are pretty reliable. You know, this is the era, early 80s. Caps were still good quality. They weren't junk. This thing was, by the way, it was made in Taiwan. So Zenith had manufacturing in Taiwan to make their lower end and lower cost stuff. This was an American company, and they prided themselves in quality manufacturing and engineering and all that. Well, this was late 70s and into the early 80s. They had to start to compete with the foreign brands that were coming in and selling, especially little black and white TVs like this. And that's why they started making these things in Taiwan, and this thing was on the same assembly line. Now there were two screws on top, one on this little panel here, which is kind of loose now. And I think there are two on the bottom. Oh yeah, did you hear? That had a good crack sound, so I don't think this set's ever been opened. And as I was saying, even though this thing's made in their Taiwan factory and was kind of on the less expensive side, I don't know what they were selling this monitor version of it, but the television that this thing came from would have been a very cheap thing. And they were still pretty reliable though. You know, caps in the late 70s and early 80s, they were not the junk that was around in the 90s and the 2000s and now. You know, stuff from the 90s just started turning to garbage. But all these 80s caps, they're just good. They're just good. All right, so all the screws are out. Let's see here. Oh, that just popped off. So this must come off somehow. Maybe we feed this through here. I don't know. Oh, yeah, there we go. All right. Goes without saying, if you don't know what you're doing and how to be safe, don't open a CRT ever. High voltages, danger, all that stuff. It's nice this thing has the isolation though. Because of this, I can actually see there's a transformer in there because the case is cracked open. But if you don't know what you're doing, do not do this. This is for informative, educational purposes only. Anything we can learn from this? It does have this little cardboard thing here. That's where you put your hand into the little stand. You can see here in the molding where there, you know, was an opening there, probably for the antenna or whatever for the rabbit ears. I also doubt that the original TV had this cream color going on. This was probably something they did for their computer or data division or whatever the thing says on the front, data science. Okay, so first observations here. There's that power transformer I was talking about. Let's reposition the camera a little bit. Yep, there it is. So big old heavy thing. Replaced where the speaker was, and let me raise the camera up because I can see where the speaker used to be. There's definitely, let me get something to point with. You can see the oval, top of the oval right there. That's where the speaker would have been. And you can definitely see where the tuner used to be, here and here. So, you know, they made some slight changes to this thing, but not everything was changed. So here's the little back panel, and there's the coil. This is for width control. So it moves in and out, and that controls the width. And they'll have a separate set of wires here that go to somewhere else. In fact, oh, it looks like actually, that's a kind of a curious thing. There's the deflection yoke. These wires go right, they go to this. That's a direct way of doing it, I guess. Yep, so horizontal deflection here. I guess if you had to add a coil in line with it, well, then you can adjust the width. So maybe the cap has something to do with it. In fact, there's another coil here. So we have a couple coils, one that's adjustable, one that's fixed. Sorry, I'm not really focused on it. There we go. And this giant cap here. And this obviously allows you to adjust things. And then the switch, which again says characters 40 and 80. Well, that obviously has something to do with the width. I don't know. We'll see. Hopefully this thing works and we'll figure that out. But here's a coax cable right here for the video signal. So that just goes right off the RCA jack. This whole PCB here has nothing to do with the video signal. That's all to do with the width and whatever the characters thing does. Coax cable though, kind of this black wire right here, makes its way down to the main PCB, which if we can get into focus here, there we go. It's dusty, but typical Zenith construction. It has silk screen markings on the top, so you can see where all the traces are on the bottom side. This is a single-sided PCB, and of course these are fragile. They can break if you drop the set or whatever. I'm just going to quickly interject while editing here. I don't talk about this in this video, but there's a bunch of space on the PCB, especially on the left side, where there's a bunch of components that are missing. And almost certainly this was probably the same PCB that was used in the original television set, and they just removed a bunch of components and then reworked it so that it was designed to run on this lower voltage from the transformer and was a computer monitor. But I can see where there was probably an IC or two and a bunch of other passive components that was probably used for the IF conversion, where it converted the tuner signal down to composite video, and also an audio processor amp or an audio amp, things like that. All stuff that's not necessary for this monitor. Controls on the back of the set. We have vertical size, vertical hold. So this is the one that's exposed through a hole. Vertical hold, horizontal hold here, or horizontal frequency. And then there's a focus control right here as well. Yeah, on early sets like this, that is not anything that's on the flyback like it is on later color sets. Now, looking at the overall condition of this thing, I mean, there's a bit of dust in here, but it's actually pretty minimal. And the back cover has slots on it, so dust can fall in the set. So even if it's not used, it can get dusty. The flyback here, you know, to be honest, it's got more dust on it than anything else. This doesn't look like soot from the high voltage. That just looks like dust. And the anode connection here, it's sticky as it gets, but that looks okay. The CRT itself, the model number is 12VCBP31. And P31 is going to be the phosphor, that's going to be the green color, and 12 for 12 inches. Later foreign-made sets especially use centimeters, so it'd be like 34 or 31 or whatever, probably 31 for a CRT like this. But this one still using inches. Zenith probably made the CRT. It does have bolts for mounting in the set. Some of these, like the TRS-80 Model 1 set, actually use a band that kind of goes around here with these straps. A little bit different mounting style. It means if you want to swap out the CRT or use this somewhere else, you have to make sure you have one that has the same compatible ears. The ears are right here where that bolt is. There are 4, obviously. From a capacitor perspective, this thing's got, this is TPO, and that looks Tycon brand. None of them are particularly good quality. It's not like it's Nichicon or anything like that. But I wouldn't be surprised if this was definitely built down to some kind of a low cost. But even though they're kind of weird no names, these are still probably good quality. I wouldn't be surprised if this thing just turns on and works. Now this is the power supply of the set. So mains comes in here, goes into the transformer directly, and there's a fuse, an inline fuse right there. So that means that no part of the mains, as I mentioned, is touching the rest of the chassis. So it's an inherently safe set. The output of this are these wires right here, these red wires. And I can see down there are 4 diodes that are going to be used for rectification. And then this thing here is the voltage regulation. So this still has voltage regulation, but I wouldn't be surprised if the voltage that comes off the transformer is going to be around 17 volts. My house runs at like 122 volts mains, and this is probably going to be like 17.5 volts or so. And then this is going to regulate it down to about 12, 12.5, 13, something like that. That'll be the B plus on here. There'll be an adjustment pot on there to make that adjustment. It bleeds off any extra voltage using this resistor here and this large heatsink here, and then that's the pass transistor. So it's a very simple circuit. It's very typical for these types of sets. So you do have waste heat. It's not the most efficient design, but it's simple and reliable. And looking at this board for semiconductors, obviously we have the horizontal drive transistor right here. There's another transistor over here, but we do have integrated circuit right there. And that's probably like a sync separator. It takes the sync signal and then it separates that out to, horizontal, vertical, goes to the rest of the drive circuitry. So I have my pointing stick pointing right to the IC. So there's that little dip IC. That is almost certainly doing sync separation or whatever. I doubt this has anything to do with the video circuitry. It probably creates the drive signal. It's like horizontal drive will then go through this transformer right here, this little transformer that I'm pointing to, and then that ends up right here at the horizontal drive transistor, horizontal output that is, and then that drives the flyback. And there's the info on the flyback if anyone is curious. Don't know, that doesn't really give us any kind of help. Now, if you think about potential problems with a set like this, if this wasn't going to work, it's possible you have some open caps here or there. Nothing's leaked. I can see nothing leaking on here, but they're not the best quality caps, right? So some of them might have leaked. Probably more likely what's happening on this thing, and don't worry, I haven't turned this thing on. I mean, I've had it for, I don't know, 6 months, a year, and I've never plugged this thing in. So there's nothing live in here anymore. Things that can go wrong on here are bad solder joints, especially because you have stuff like the flyback here that's heavy. That can create some breaks, maybe on some of the other large components. You can get cracks in these PCBs if the set was dropped. I don't see any signs of that on here, but sometimes it can be kind of hard to tell. They have some good wire management in here, so it's not easy to pull this out, and everything is soldered together or wire wrapped. Like the transformer here, this is wire wrapped onto the PCB, so I'd have to take that out to even get this thing fully out. Obviously the deflection yoke, yeah, all this stuff is wire wrapped right onto the PCB. There's no connectors of any kind. That just makes it that much more difficult to service this thing, but it wouldn't take that long to get it out here. I don't think I'm necessarily going to need to do anything though, but yep, those are some of the typical issues. Dirty pots, of course, can cause problems, especially the ones that are on the front, which they're not on this PCB. There must be some kind of a little circuit board down there, has the power switch on it and the front pots. If those are dirty, I'm going to have to get contact cleaner in there because you might get no video signal, for instance, if they're too dirty or scratchy. One thing to consider is that this coil here, or these coils, are actually hooked up directly to the horizontal deflection, right? These will be carrying some pretty high voltages. This cap here, though, there's a couple things about it. It's bipolar, so you cannot just replace this with a regular polarized electrolytic capacitor. That would be bad. So if you're changing out the caps on a monitor like this, do not change this unless you find yourself a bipolar cap. It's rated for, it looks like 10 microfarad at 25 volts, I guess. Actually, that's not very high, the voltage. So I don't know how that's actually hooked up. But considering how large it is, you figure that it's actually going to be carrying a decently high voltage. These days, a 10 microfarad cap wouldn't be so big. But the fact that this seems to be hooked directly up to the deflection yoke and obviously controls horizontal size means it has something to do with that, I guess. So I don't know. But anyways, just be careful switching out caps. You gotta watch for the fact that it's bipolar. It says BP on here for bipolar, so there's no polarity, but that's just something to watch out for. All right, well, I've done enough looking around. I'm confident that nothing looks out of the ordinary. I don't see anything broken in here. There's nothing leaking. It all looks okay. I think it's just time to try this thing out and see if this works. What I'm gonna do is I'm gonna plug the power cord into this little switch thing here. And that's because I don't know on the front which is on and which is off. So I know for sure that the power is off, and then I can turn this on and turn it off quickly if things go catastrophically wrong here. So it's currently set to off. Now, when it comes to working on sets, if they're live hot chassis, you want to use an isolation transformer. I don't need to do that here because this thing has an isolation transformer right here. So nothing really to worry about. I think the first thing I'm going to do is turn it on with the set facing this direction, because if anything goes catastrophically wrong and fireballs shoot out of this, we want to catch that on camera. So I'm going to turn the switch on here. I don't know if the front's on or off, but let's see what happens. I can hear the transformer in here buzzing, 60 hertz hum, when I turned it on. Now, I don't know with the power switch if the power switch is, well, where is the power switch wired in? I think it's these wires right here, meaning it's after the transformer. So the transformer just runs all the time. That's kind of a bad waste of power. So if you have one of these sets, you might want to just turn it off at the mains and don't use the front power switch. I'm going to turn the switch to the other position. The set's currently off on the main switch. And here we go. Aha. Okay. I heard high voltage. Don't know if it's displaying anything, but it sounded like this thing came up. I'm going to turn the power switch off on the wall. I'm not sure if high voltage is actually running on this thing. All right, so for testing that the monitor is actually working, I'm going to use my Android phone with an app called Spectroid. It's a free app from the Play Store. I'm assuming with other phones there's stuff that's similar. What I like about this is on the Google Pixel, at least, the microphone is good for up to about 25, 26 kilohertz. That means if you have a monitor that runs at any of those scan frequencies all the way up to that, then you're going to be able to actually see that on the graph here. So I currently have this scaled. Let's move this a little bit here by pinching to zoom. So 15 kilohertz is right in the middle there. And all we need to do is turn on the TV with the phone next to it. And this should, if the set is working and generating high voltage, then we should absolutely get a nice peak in the middle. Now, flyback is right here, and the deflection coil and all that stuff is going to be what's generating that sound that young people can hear, but I can't really hear anymore as I get older. I can just barely hear it. I'm almost 50. That is normal. You kind of lose your hearing as you get older. But young people, that 15 kilohertz sound that TVs make, yeah, it's pretty loud for them. It was for me when I was a kid, but your hearing just over time gets damaged from daily life, and you lose that ability to hear that high-pitched sound. So here we go. I'm going to turn this on the wall. Hey, there it is. All right, well, one thing that's interesting, well, you can tell the set is running, but also notice how it went, like the frequency kind of like ramped up. Now what's wild is this is free running right now, and it's very loud. So I think to a person who had sensitive hearing, they would hear this very clearly. 15.1 kilohertz is what that's running at now. So I'm going to hit play on here. Oops. So I'm going to hit play, and I'm going to demonstrate that I can turn the horizontal hold control, even though no signal is connected, and the oscillator is free running. And that means that that peak's going to move. Watch this. So it's going down. We're now at like 14 point something, and I'm raising it up as well. And now it's at 16 point whatever. Actually means that this set can probably connect to a video source. There's quite a bit of range in there, but it's tuned to run at 15.7. It's going to generate the proper amount of high voltage at that point. So while it's free running here, I'm just going to adjust this horizontal hold control to be exactly or as close to 15.7 as I can. And hopefully you can see that, 15.750 hertz. And you can see me adjusting it on the display down here, but that's a very useful tool. So this monitor is generating high voltage right now. It is absolutely generating high voltage. That means that it's not safe to touch anything inside the set here, because it is absolutely high voltage is being generated. But you know, there's high voltage coming out of the anode cap there. Not to mention, you don't want to touch the coil area here, the connections, because that's probably like 300 volts or something. And even this thing down here, this is probably high voltage as well. Now, the reason why I have the lights off, let's turn this set this way, is I want to show probably have some glow, if I can get this in focus there, coming out of the neck of the CRT. You see that little bit of white glow there? That would be coming from the B+, which is probably around 12 volts, like I said. And that's typically what these types of CRTs run off of. I'm going to reach to the back wall and turn off the set. Can I get closer? Okay, let's try this here. So I'm going to turn it on, and that should slowly fade up. There it is. I'll point to it. You can just see it right there, that glow. That's the actual filament inside the CRT. So it's working. Now, of course, we're generating probably high voltage. It doesn't necessarily mean that we have an image, right? There could be other faults with the set here. I'm just trying to turn it carefully here. I don't want that little video width board thing to hit anything. Oh, hey, there's a freaking raster. All right. We have a raster. One of the other things about having the lights off makes it that much easier for me to see. I'm sorry for the roll there. I'm going to have to adjust the camera so it's locked at 60 hertz. It kind of is going in and out of 60 hertz. Now, the reason why it's rolling right now, the camera is running at 1/60th of a second. This should not be rolling, but the vertical hold control controls the horizontal or the vertical frequency, and that's probably out of adjustment too. So I'm going to reach back here, and I'm going to turn that. That's a little hard to see. Let me see if I can turn up the brightness and contrast. Okay, these spots are scratchy. Oh, there we go. Right, so watch this. So if I adjust the vertical hold, see how that bar is moving? And that's because it has a free running oscillator right now. That's going to be in that little chip there that we saw on the board. And this is adjusting the frequency, the vertical frequency, and the horizontal hold adjusts the horizontal frequency. Now, a few things I can tell by just looking at this here is it looks like there's some, I don't know, ripple over here on this side of the screen. Probably coming from the caps. They're probably not in the best shape. Although, I mean, the geometry looks good. There's a little bit of a bow on the top here, but we don't have a good signal going into this thing right now. And you have to remember, this thing was designed not to display video, like as in from a VCR. This thing was really designed to be used like an Apple II with monochrome display. Apple II does not output any kind of gray shades of gray. It's just black or white. And that's what this thing would have been ideal to use with. Now I'm just holding the little width board. Now if I flip the switch here, well, that's interesting. The image definitely got much wider. I'd have to hook up my test pattern generator to see exactly what that did. But it seems that flipping the switch like stretched the image dramatically. All right, so I have the test pattern generator hooked up. It's not very bright right now. Okay, contrast knob. That's the white level, right? And it's a scratchy pot, but that's working. That's a pretty bright image. Now, green CRTs like this, they seem to have really good longevity. They last a long time, and that seems to be the case with this one. Let me flick that switch, and let's see what that does exactly here. Oh, yeah, okay. So it really brings in the image. Maybe on some early computers, 80 column text was very close to the edge, and therefore you wanted to be able to not have overscan. You notice that way this is set up right now, we have a black border. So this is displaying the entire NTSC image right now, every single line of it. We can switch here to the color bars. There's the color bars, and yeah, we can kind of see that ripple going on right there. But we're seeing the whole image there on the screen with nothing wasted. Now let's see. Okay, so brightness works as expected. Yeah, I mean, other than this ripple that's happening right here, which, like I said, is probably a cap in the cathode drive. So what's happening is the beam scans across, it shuts off, and in the retrace, it sends the beam back to this side, and then it turns it back on. And then when the beam current is turned back on, it goes up, and then it bounces, and then, you know, it's fine across the entire image, and it's even fine right here where it's going from light to dark. And then it's shut off and, you know, brought all the way to black, which brings the voltage all the way up, and then you get this bouncing here. So in the cathode drive circuit, there's a cap that is almost certainly at fault causing this ripple, or the design of this is just such that it's always had that ripple. It might be, that actually might be the case. Now with the coil, when it's at its extreme end, one end or the other, it doesn't really do anything. but I don't want to turn it too far because it could damage it. Could be damaged already. Yeah, it doesn't seem to be doing anything. There's a slug inside the coil. As you turn the knob, it moves the slug in and out, you know, in the position of the coil, and that changes the value and the inductance of the coil, and doesn't seem to be doing anything. So I need to take a look at that. I'm going to kill the power on this thing here. Oh, nice that. No flash or anything when it turns off. And I'm going to take a look at the coil. Okay, I could definitely see the problem there, that the slug was all the way at the very top on this red coil here. It was just peeking out the top, and moving it around in there doesn't do anything. You need to move it down in between these coils and closer to those, and that's what changes the value. That's these two coils, and moving that slug around is what changes it. Yeah, it's the fact it was stuck way up here, that's why I wasn't seeing anything. So I'm turning it clockwise and the image is getting wider. If I turn it counterclockwise, it's getting narrower. And if I flip the switch, it's definitely more apparent. See the wider, narrower. Okay, I have a tool inserted into vertical size control. That works as expected. Oh, that's interesting. The image is now rolling. So I'm adjusting the vertical size, but the vertical hold is affected. So no problem, I can lock it back on. It probably changes slightly as you adjust the size. It actually changes the frequency. So what I can do is keep adjusting this pot. So I can keep adjusting this. Okay, so the minimum amount is that. And that's the max. Interesting. So it's giving us borders even on the max setting, which really just means that if we hook up an Apple II to this thing, we're going to end up with quite substantially large borders. Now I can flip the switch here. Wow, that actually, when it gets wider, flipping the 80/40 column switch, it actually shrinks down a little bit. It's possible one of the caps or some value has drifted on some component that is causing it not to have full deflection, but it's also possible that's just the way this monitor works. You know what's funny? The control for the width doesn't seem to do anything when it's set to this wide mode, 40 columns, I guess. Let's look at the control. Yeah, 40 column mode. It doesn't seem to do anything. The control only seems to have an effect in this mode here. So you see it's getting wider, and the slug is coming out there, so I can't go any more than that. But if we switch to this one, and I turn it the other way, it should be shrinking the image. Let's switch to this one. I guess it is. I guess, oh, it's having an effect, just not a big one. The image is also getting dimmer as well. I think what's happening with the dimness is the deflection yoke and that coil on the back is all part of the circuit that generates the high voltage. And I bet you the high voltage is changing depending on the switch setting, and turning that knob and adjusting that coil seems to make the image get even dimmer in this mode, that is. And I bet you it has something to do with the high voltage changing. We should measure that. So I brought the image in pretty much as it can go. And if I turn it the other way, which is widening it, is it getting brighter? No, I guess it's not. Still seems dimmer than I think it should be. I don't know. It's definitely brighter in this mode, that's for sure. All right, the high voltage probe is stuck into the monitor here. Let's turn it on. Yeah, we're only getting about 8 kilovolts. That's not a lot. Let me flip the switch. Definitely changes when you flip the switch. Let's see if it's in the dim mode or the bright mode. Ah, okay. And to be honest, a 12-inch CRT like this should be running around 12 kilovolts, not down around, just make sure I have a good connection, not down around 9 or 8. So it's a little low, but the image looks really good, so I don't know. That may be normal, but that definitely seems on the low side for the high voltage. Now, when it comes to high voltage on a set like this, there's not a lot you can do to adjust it. It's not like it's something that is adjustable. It's all just part of the same circuit there. So, yeah, I think this was lower voltage. This was like the 8 kilovolt mode, and it seemed to be brighter in this one. I don't know. So with this monitor, I'd love to hear from anyone who's ever used one of these. I know they're not the rarest thing in the world, but they're all not super common anymore just because of how old this is. Was this normal, this amount of underscan? Or is this thing just have components, passive components have gone bad, caps, and maybe things have drifted or whatever, that doesn't allow me to adjust the size to actually overscan the entire thing? Because typically with an Apple II, it's really designed for a monitor, like a TV, that's got overscan. Otherwise, if we plug in an Apple II like C or something, we're gonna have giant borders. And that's just because, well, even right now, as you can see, this thing is not overscanning. It does overscan if I flip the switch, so the borders would be not terrible on the sides, but then we have the whole top and bottom thing where there is just not enough vertical size. Now that potentiometer has a little capacitor right next to it that perhaps is bad or open or something, and that's causing this to not have enough range. I don't know. The thing is, a potentiometer typically has a couple of resistors near it, and that's really what controls the size. Not, I wouldn't say it's normally cap related, but it may well be. I'd have to look at the circuit design to know for sure if a cap was worn out. And maybe I should try to get that cap out, and I'll measure it and we'll see if I can fix this. Actually, you know what? Before I do any of that, I'm gonna go look at the circuit diagram to see what controls vertical size, so I don't just willy-nilly take out a cap that has nothing to do with the vertical size, because that's clearly the shotgun approach, and I don't like doing that. So, time for some research. So someone uploaded the service manual for this exact monitor to archive.org. So thank you very much to whoever you are, if you happen to be watching. And sure enough, looking at, just make sure this cord's out of the way, looking at the service manual, it is cap 609 that is related to the vertical circuit. And everything's unplugged right now, by the way. Here is the cap. This was the one that was right next to the potentiometer. 16 volts, 10 microfarad, which is exactly what's in the manual there. Doesn't look like it's damaged at all, but it's old and it might be open. Let's grab the old LCR meter here and let's see what we see. So that does not seem like a bad cap. That seems like a completely good cap. All right, so sorry for filming the screen, but that's how I'm doing it with the camera here. So that is the vertical amplitude right there. There's the potentiometer to adjust the size. It basically looks like it's kind of a voltage divider for the base drive that goes into the transistor here. Here's the cap that I just checked, and it's definitely working okay, not a problem. And yeah, so I bet you I have to change one of these resistors here around the amplitude to actually get more amplitude. Although there's a vertical amplitude 2 transistor here, it's sort of cascade setup. And there's another cap there, but I don't think that's got anything quite to do with it. There's a push-pull arrangement of these 2 vertical output transistors here, and that goes into the coil. There's the coil right there. I mean, I suppose it's possible. What other caps are around here? There's a 220 microfarad there. I suppose if that was weak, it wouldn't get enough amplitude. So that's going to be worth checking. C614. All right, this is the other cap here. This is a different looking cap. Tycon, 16 volts, 220 microfarad. It's not bulging or leaking or anything like that, but let's test this one. This is the other one that's involved with vertical deflection. That looks good as well, 216 microfarad. I mean, I have it out, I might as well change it. I ended up changing the other one that was in here. I put a Rubicon in there, the 10 microfarad. And I didn't have another 10, so I put a 47 in there. Should be fine. Let's compare the one I just took out here to another cap here, one that is brand new. Let's see what this reads. All right, there we go. I switched it into ESR mode. So 1 kilohertz. This is that 470 microfarad cap, 361 at 1 kilohertz, 0.45. Now, if we change the frequency, I don't know what well, it's actually going to be running at like 60 hertz. So now we're getting 399 microfarad at 100 hertz and 0.6. And if you go to this Sanyo cap here, I'm going to pop this one in. This is the one that's 50 volts. Yeah, 216.4. And 16 volt Nichicon, 1000 microfarad, 0.1 ohm. So that's nice and low. Unfortunately, I dropped the original cap I took out of this thing on the floor and it went boom and flew away. Okay, found it. Here it is. Here's the original cap. Let's see what this reads in ESR at 100 hertz. Okay, 0.7. So yeah, it's not great. It's not doing great, but That's not, if this was like 2 ohms, I'd be more concerned. That's okay. Because I removed the original cap, I'm just going to reinstall this Sanyo 220 microfarad 50 volt cap in place of the original one. And let's see if that makes any difference. I don't think it's going to make any difference at all, but let's just see. Ready to test this. I have the caps reinstalled, just push the board back in all the way. Everything good to go. Yes, video is connected. This is off. And here we go. Turn that on. I don't think it's going to make any difference at all. Those caps were fine that I took out of this board. It kind of shows, yeah, that did absolutely nothing. Nothing at all. I'm quite sure I have this turned all the way to the max. Yep, that's it. Won't go any more than that. Yeah, that made no difference whatsoever, which is exactly what I thought would happen. I'm pretty sure what I'm going to have to do to make this work better is adjust some of those resistor values, but that is where I don't really know what I'm doing when it comes to the analog magic around the potentiometer here. There's 1.2 meg, a 620 there, it's a 300K on the potentiometer, and we have 470 there. It's gonna be one of those, we can adjust those values, and that will allow us to actually get more size out of this. All right, what I'm gonna do now is just adjust the focus on here. You know, to do it properly, I probably need to hook a computer up to this thing because I think looking at the dots on here is just not ideal. Let me grab a computer. All right, I have the Apple IIe out on the bench here. Let's turn the monitor back on. Hopefully this computer works. You never know, it might have broken or something since I last used it. Nope, it works. That's quite the border we got going on there, isn't it? Quite the border. I mean, that's actually kind of ridiculous. It's what I said would happen, though. If we flip the switch, though, on the back, at least horizontally, it won't be so bad. Oh, that's just the bad cable. All right, and let's try to make it wider. I think I'm at the limit already. Let's see here. Yeah, it's shrinking now. Okay, so it was already as wide as it can get. All right, well, anyways. So there it is, as wide as it can get. And we still have a pretty sizable border. And of course, on the top and bottom, we do as well. Hey, the 2E's working, so that's excellent. Let's go to PR number 3. So we can get some 80 column action here. Oh yeah, that is pretty sharp. Quite happy with that. Let's run a little program here. Oh dear. I thought the computer was working properly, but I guess we have a fault on the Apple here. I was just trying to run a little basic program that simply, oh, and it rebooted itself. Well, as I was saying, I was just trying to write a little basic program that simply printed a hash symbol across the entire screen. I'm assuming I have like a bad connection on a chip there because it's like when I hit the enter key, it is when it did that corruption there. Yeah, that's fine now. All right. Oh boy, we're having a focus hunting issue there. All right, I'm going to use this hash pattern to help me adjust the focus control. First of all, we've got to get the brightness and contrast set appropriately. Yep, that looks good. All right, strangely enough, the focus appears to be best when it's turned all the way to one extreme. Yep, that's definitely the most focus right there, having it turned all the way clockwise on this monitor. And absolutely looks the best there, yep. Looks quite good though, gotta say. No complaints about the sharpness on this monitor. Very nice. So I'm gonna say that set to the 40 column mode, my only complaint is I wish I could just get more vertical size so we could shrink a little bit of this border. More horizontal width would actually be nice as well, but it's currently set as wide as it can get. And you know what? What's interesting is that slug on the width control was set to the widest possible configuration when I opened this monitor, and that's how it is right now. So I'm assuming whoever had this monitor before, way back in the day when they were using it, they had to do the same thing as this. And maybe this problem with the height is just a design flaw with this monitor, and well, like I said, a resistor is going to need to be changed. For the resistor fix, I'm going to ask my friend Frank, IZ8DWF, about what to change. He'll know exactly what to do, so I'll maybe do a follow-up video on that, or I'll post a comment down below just letting you know if that fix worked to increase the size of this thing. It's possible with the swapping of maybe a capacitor on the deflection circuit, horizontal deflection, we could make it a little wider as well. But I think this is actually okay the way it is here. It just needs a little bit more height. So that's going to be it for this video. It was fun playing around with this monitor. As I suspected, there is nothing wrong with this. It could use a little cleaning on the pots, barely. But this thing, I mean, being built in their Taiwan factory doesn't seem to affect the quality because it's still a great, reliable monitor that still works after all this time. And even though I took out those two caps, which I suspected could possibly be the problem with the vertical size, they measured fine on the meter. They probably were like that when this thing was built in 1982. And even cheap caps in 1982 were better than the junk we are dealt with these days that just fail and go bad or whatever. Every single cap on this monitor still works, and it wasn't even built at a fancy factory. I don't know where this Zenith monitor fit into their product line. As a kid, we had an Apple II Plus in the house, and it had a Zenith monitor from same Zenith data system, but it wasn't this TV one. It was an amber screen, and the controls were on the bottom, and it didn't have this whole side thing. So I think that was actually a purpose-built computer monitor, but it may have been added later. Oh, that's fine, by the way. Don't worry about that. That's the soft switches being read as I was reading out the entire memory space. That just happens on the Apple II. Going back to that original monitor, I think this is an older design, but I'm not 100% sure. So if you know more about these Zenith data systems, monitors, and the other stuff they had, let me know. And if you know what television this was based off of, also let me know. One thing I can tell for sure is clearly they had the Apple II in mind, because this color here definitely matches the keys, well, more closely than on the Apple II Plus, that is, than on the IIe. This color here and here is like a dark brown, and then the beige color absolutely is a perfect match for the Apple II. And this is one of the painted Apple IIes, one of the early versions. So it's got the same color case as the II Plus, and you can tell it's an absolute perfect match. So clearly Zenith had the Apple II in mind when they were making this thing. But then the question is why does it have this giant border if they had the Apple II in mind? Because that's just excessive. But maybe that's what they wanted to do. I don't know. Who knows? If you know more about this, so let me know. And yeah, I think that's it. If you enjoyed this video, thumbs up. If you didn't, you know what to do. Thanks to my patrons. Names are going beside the screen. And that's it. So stay healthy, stay safe. I'll see you next time. Bye.